This is LeetCode question 852, big index in a mountain array. This is easy question. Let's get into it. Let's call an array a mountain if the following property holds. Length of A is need to be bigger than 3. There is some 0 is smaller than 1, and then 1 is the smaller than A length minus 1. This one is the max index. Such that A0 is the smaller than A1, A1 is smaller than AI minus 1, AI minus 1 smaller than AI. This one is the value what we're looking for, and then this one must be bigger than A plus 1, A plus 1 bigger than the max index of array. Okay, let's check with example 1. In this time, 0 is here, 1 is here, and 0 is here. So this shape the same as mountain. And then we need to find this value. Okay, let's check example 2. This one is here, and then 1, 1. So we need to find here. Okay, how we can find it? Yeah, that's right. We able to scan a whole array and then find the max value, because this is the maximum value of array. And then second is we find the moment value is start to decreasing. This time this 0, 2 is increasing and 2, 1 is decreasing. So this time is we are able to find the value. So this is second. Can you make it better? Okay, then how we can optimize? Because we do not use any space complexity, so there is only one way to is time complexity optimization. But how? I will show you the one idea. Okay, let's see. Example 2, A is given like this. At this time, this one is does not solid, but so maybe we cannot use binary search. Is this true? No. Even this one is not solid, we can use binary search. How? Okay, I will show you. Actually, this one is the same value and then decrease, so we cannot use item itself. But if we convert into another, we can use. In this time, I'm gonna use this one is true and false, and then to be that, I need this one condition. Condition is AI is smaller than AI plus 1. Okay, according to this condition, this one must be 2, because AI is the smaller than AI plus 1. So this one also 2. But this one, in this case, but this one is AI minus L, this one is false, right? So this one is false. So we needed to return value here. Does it make sense? Okay. But how we can use this one with binary search? Okay, I will show you. Okay, this one's okay. Binary search we based on two-pointer technique, so I will make two-pointer left and right. So left is initialized with left side of array, and then right also right side of array, and then we can find the middle number maybe around here. Yeah, okay, around here. And that time we can check this one plus this one is true. In this case, this one is true, right? So in this true means we can choose which one is the area we're looking for. Actually, here is the value we're looking for. So in this time, we will move the left pointer to mid plus 1. Now let's recalculate the mid value. Mid value may be 1, 2, 3, 4, 5 around here, right? So let's check. This one is first. In this case, how we can do this one able to move, right? Then we can reduce boundary to search. Now we needed to find right value is mid minus 1 or mid. Which one is right? Yes, that's right. We needed to do mid because the target we're looking for is always mid minus 1, right? So that is the reason why we right side is not mid minus 1, mid. Because looking for here is always one step ahead of right value. And then now here, and then looking here, and then like here, and then now this value is we looking for, so we return here true, and then we return left value. Did it make sense? Okay, good. Okay, let's implement the code. Left is 0, right is length a minus 1, while left, which one is correct? Bigger or smaller equal? In this time is only smaller because we needed to compare two items, and then calculate the mid value, right minus left divided 2. So initially is left. The reason why I implement like this is I will prepare overflow. Prevent overflow, prevent. And then now we're checking if this one, I will use this condition, a mid is smaller than a mid plus 1. I will, this time I needed to increase left side. Left is mid plus 1, as right is mid, same as I mentioned before. And then which value we need to return, left or right? In this case left, right? So return left. Okay, good. In this case, time complexity is log n because we use binary search. Space complexity is constant because we do not use any data structure. Thank you.